Good morning, everyone. Today we're gonna talk about chemical reaction. First, we're gonna define physical change and chemical change. So, physical change are changes affecting the form of a substance, but not its chemical composition. While a chemical change occurs when a substance combines with another to form a new substance. This turns into chemical reaction. Actually, there's no difference between chemical change and chemical reaction. The only difference is the definition. So, let's define chemical reaction. A chemical reaction is a process that involves rearrangement of molecular or ionic structure of a substance. As we can see here in the examples, hydrogen plus oxygen yields water. Two different substances combine together to form a compound which yields a whole new substance. Iron plus oxygen yields rust. Water plus carbon dioxide plus light yields glucose and oxygen, which is photosynthesis. So let's hop on to the next point we're going to talk about today, which is how we can prove that a chemical reaction is occurring. So we have a lot of evidence, but today we're only going to talk about five of them. And they're very obvious and very noticeable. So we have color change, smell, formation of gas, permanent change, and temperature change. Color change, we have here an example for rusted metal. So metal, when it's rust, it turns brown, and metal itself have metallic silver color. So there's a huge difference between the two colors. It's very noticeable, as you can see here in the picture. Second evidence is smell. When you leave something outside the fridge or you leave it in the fridge and you forget about it for a long time, how do you know it turned bad or it's still good? You smell it. If it smells bad, it's probably rotten and you should throw it out. And if it's good, it's still good to eat. Like rotten eggs. Rotten eggs smell really bad. If you smell a really bad egg that's rotten, probably do not eat it. Same with milk. Next, we have formation of gas. So when you're in a scientific lab and you're doing an experiment, and your beaker starts to bubble. So this bubbles is an evidence that a chemical reaction is occurring or occurred. So it's a very obvious one. Everybody knows it. Very noticeable. Next, we have permanent change. So when you change something and you cannot turn it back into its original form, like burning wood, it turns into ash, and ash cannot be turned back into wood. Actually, in this example, we have another evidence that a chemical reaction has occurred, like color change, from brown to black, and the smell of burned wood, and formation of gas. When you burn wood, carbon dioxide comes out. So there's a lot of evidence that burned wood is a chemical reaction. Fifth and final one is temperature change. When we let up firework and it burn into the sky, this this colors come out because the powder inside the fireworks burn into the sky and turn on fire, and this is why this colors come out. So let's hop into the next point we're gonna talk about today, which is types of chemical reaction. Actually, we have five types, which are combination, decombination, single replacement, double replacement, composition. So we're gonna talk about each one separately. We're gonna define it. We're gonna give an example. So let's start with combination. Combination is a reaction in which two or more substances combine to form a new single substance. The general form of combination reaction is A plus B yields AB. One combination reaction is two elements combining together to form a compound. Here's an example. Solid sodium metal reacts with coralline gas to produce or yield sodium chloride. So we have two substances. A is sodium, B is chlorine, turns into sodium chloride. Next, we have decomposition. Decomposition. A decomposition reaction is a reaction in which a compound breaks down into two or more simpler substance. So actually, decomposition is the opposite of composition. So here we have AP turns into A plus B, and in composition we have A plus B turns into AP. So Most decomposition reactions require an input of energy to break down the compound into simpler substance. And this energy can come in heat, light, or electricity. Here we have an example. Mercury oxide, which is solid, decomposes when heated and yield mercury, which is liquid, and oxygen, which is gas. Um, let's go to the next one, next type, which is single replacement. Single replacement is a reaction in which one element replaces a simpler element in a compound. The general form of single replacement is A plus BC yields AC plus B. In this general reaction, element A is metal and replaces element B, also metal, in the compound. When element is doing the replacement is non-metal, it must replace another non-metal in a compound. The general form for the equation, which is non-metal, is Y plus XZ yields X Y plus Z. So the replacement must have the same like type, metal or non-metal. Here we have an example. Magnesium plus copper nitride yields to magnesium nitride and copper metal. So let's go to the next type, which is Doppler replacement. So in a Doppler replacement is a reaction in which the positive and negative ions of two ionic compounds exchange places to form two new compounds. And here's the general form: A plus B. No, wait. AB plus CD yields AD plus CB. So we have an example. Potassium iodine plus lead nitride yields potassium nitride plus lead iodine. There's something I forgot to say about double replacement. So AC are positively charged and BD are negatively charged ions. In order for a reaction to occur, one of the products is usually solid precipitate, a gas, or molecular compound such as water. So let's go to the final one, which is composition. Composition reaction is a reaction in which a substance reacts with oxygen gas, releasing energy in form of light and heat. Composition reactions must have oxygen or O2 as a reactant. The composition of hydrogen gas produces water vapor as seen here in the example. Thank you for listening. Hope you enjoyed and learned something today. Thank you.